Alright, Newton's second law of motion is lesson 3 for chapter 2. Your vocab slide. Newton's second law of motion states that the acceleration of an object is equal to the net force acting on the object divided by the object's mass. And we'll go into a lot more work with that. Circular motion is any motion in which an object is moving along a curved path. Centripetal force is a force that acts perpendicular to the direction of motion towards the center of a curve in circular motion. So, force is changing motion. Velocity is changed by unbalanced forces. Unbalanced forces act on an object at rest in the direction of the net force. So our example here is a ball being held in your hands has equal forces. One is gravity pushing down on the ball, and the second is your hand holding the ball up. If you move your hand, you no longer have balanced forces, right, because you are no longer holding the ball up. Therefore, the net force is in the direction of the ground because gravity is still acting. And that's what causes the ball to fall, when those net forces are unbalanced. In this case, again, we've taken our hand out, so we've unbalanced the force, and it falls in that direction. Forces changing motion. Unbalanced forces act on an object in motion as follows. If the net force and the velocity are in the same direction, the object will speed up. If the net force and the velocity are in different directions, the object will slow down. So what we're talking about here is if we have a net force, say that first arrow, we will say is a force of 5 newtons going towards the left side of the screen. If we have 2 newtons on this side, our net force is going to be 5 minus 3 because they're in opposite directions. So we have a net force of 2 newtons to the left side of the screen, so the ball would be speeding up. If we did the opposite example, and we did 5 newtons going to the right, and only 2 newtons, don't want to do that, and 2 newtons coming from the left, right, so we have a greater force going to the right than we are coming from the left, the ball would be slowing down in this case. We're provided that the ball is supposed to be moving in the left direction of the screen. Force is changing motion. A force can cause a change of direction as follows. If you hit a pool ball that travels at a consistent velocity, then hits a rail, the rail acts as a force in the opposite direction of the velocity. So it's not moving, but it acts as the force. And therefore, it changes the direction of the ball. When the velocity is caused by an unbalanced force, you are accelerating. So a change in velocity is acceleration, we know that. So what we're saying here is if this ball is hit in this direction, so right there, right, with our arrow ending right here, and what happens is as it hits the rail exerts the exact same amount of force back in the opposite direction. The arrow doesn't do a very good job of representing, but these two arrows should be equal. Because again, we're just redirecting the same amount of force. Newton's second law of motion states that the acceleration of an object is equal to the net force as acting on the object divided by the object's mass. This is also written as acceleration, or A is equal to F divided by M. More commonly, you see that as F is equal to M times A. So acceleration is equal to force divided by mass, or force is equal to mass times acceleration. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. So practice. If you throw a 0.5 kilogram ball, or a basketball, with a force of 10 newtons, what is the acceleration of the ball? First, you write down what you know. We know that the mass is 0.5 kilograms, the force is 10 newtons. We know our formula, and we will be using A is equal to F divided by M. We plug in our variables. This is all 3 different versions of the formula, by the way. If we're solving for F, we put F by itself. For A, we put A by itself. For M, we put M by itself. We plug in our variables. We know mass and force. So we can plug those two in, multiply them, we get 5 meters per second squared. We'll do some practice with this in class as well. Second practice. A 30 Newton net force on a skater produces acceleration of 0.6 meters per second squared. What is the mass of the skater? Again, you write what you know. We know that the force is equal to 30 newtons and the acceleration is 0.6 meters squared. Our formula, again, we're going to be looking for m is equal to F over A. We plug in for our variables, 30 in for force, 0.6 in for acceleration. We solve by dividing those two things to get that the skater weighs 50 kilograms. Our last practice here. What net force is acting on a 14 kilogram wagon produces an acceleration of 1.5 meters per second squared? What you know, again, m is equal to 14 kilograms, a is equal to 1.5 meters per second squared. Our formulas, we have all three varieties there. Plug in our values for our variables. This one we're going to be using F is equal to m times a, so 14 times 1.5 meters per second squared. We solve to get that the force is 21 newtons. Circular motion is motion in which an object is moving along a curved path. So any object that is moving along a curved path is in circular motion. Centripetal force is the force that acts perpendicular to the direction of the motion. So if that's circular motion, that is. So the force, centripetal force, is towards the middle of the circle. When swinging something on a string, it's inertia and centripetal force that cause the ball to move in a circular motion. And we'll see that in our next few slides. So if you're swinging something around on a string, velocity is always wanting to go in the straight out direction. So we're saying this is a straight line, it wants to keep going in that straight line. But inertia is going to keep it in motion while centripetal force pulls it back in. So this is our centripetal force coming back in towards the axis. Our velocity is going to be going away from the axis. Again, here's our circular motion. Our blue object is going to be going in circular motion. Our centripetal force would be going from the blue object always in towards the red object. So it's always changing the direction that it's facing, but it's always going towards the axis of the circle. And that will do it for lesson 3 notes.